Today's lesson is about solving inequalities. We're going to use most of the same concepts that we used when we solved equations, but we're going to add a rule to those concepts for particular types of inequality problems. Let's get started. The concept we have to review is inverse operations. If you remember, when we solved equations, we used the concept of inverse operations to figure out the solution to our problems. So we're going to do the same thing with inequalities. So when we go to solve inequalities, we're going to look for inverse operations. What are inverse operations again? Well, inverse operations are operations that undo each other. So if you remember, addition and subtraction are inverse operations, because when you talk about adding or subtracting inverses, the answer to that problem will always be 0, so one will undo the other. As a review, some examples of that: -8 and +8, those are inverses or opposites. When you add them, they equal 0. 5 minus 5, so if you start with +5 and you take 5 away, that's opposites or inverses. The answer is 0. They undo each other. Multiplying and dividing works the same way, except the answer to the problems will be 1 instead of 0. So if you remember the inverses that we talked about, 8 divided by 8 is 1, and 1/8 times 8 is equal to 1. So we're going to use those concepts again, like I said, to solve our inequalities. So the one additional rule I mentioned when we first started the video, that one additional rule is that when you divide or multiply by a negative number, the sign in the inequality flips or gets switched around. So the less than will turn into greater than will turn into less than. Whatever the sign is, it switches to the other one. So why does that happen? It's a rule that you have to do. I want you to understand why it happens. I'm going to show you by giving you an example. Okay? So what we're going to see is that when both sides of an inequality are multiplied or divided by a negative number, the solution is no longer true. So here's an example. We all know that 5 is greater than 2. It's pretty simple for a middle schooler to figure that out. If you use a number line to help you figure that out, you'll see that 5 is to the right of 2 on a number line. Numbers to the right get greater, 5 is greater than 2. But look at what happens when we multiply both sides of this inequality by -1. Remember that we said that you can do the same thing to both sides of an equation, and the equation will stay equal. Well, with an inequality, that happens most of the time, but when you multiply or divide by a negative number, look at what happens. -5 is greater than -2. This statement is not true. -5 is smaller than -2. If we use a number line to confirm it, you'll notice that -5 is to the left of -2 on a number line, which means that -5 is actually less than instead of greater than. So when we multiply by a negative number here, or if we were dividing by a negative number, it would make the inequality that you get as your solution untrue. So how do we fix that? We fix that by flipping the sign, like you can see right here. So if I flip the sign after I do my work, now it says -5 is less than -2. That statement is also true, just like the beginning statement that we had, 5 is greater than 2. Since that's true, we can use that as a rule, because that will be true every time. If you flip the sign in a problem like that, it will create a true inequality. Okay, so let's look at a couple examples here. So when we multiply or divide by a negative number, we're going to flip the sign. Here's our inequality. -5x is greater than 25. So if you remember, the symbol that would go between the -5 and the x is multiplication. If you think about the inverse of multiplication, the inverse of that is dividing. So we're going to divide both sides of this inequality by -5. Okay? The -5's cancel out. -5 divided by -5 is equal to 1. That's the inverse operations property we talked about. So we're just going to be left with an x on the left-hand side. And 25 divided by -5 is equal to -5. So what we have to keep in mind, though, is that since the red number here is negative and we're dividing, we need to switch the direction that the sign is pointing in. So that greater than sign is going to turn into a less than sign. Okay? So our solution, or our solution set here, is that x has to be less than -5. So what that means is if we put numbers less than -5 in here, we will get true statements. Okay? And we can test that out. If we put -6 in here, -5 times -6 is +30, which is greater than 25. If we put a number in that's greater than -5, let's say 0, that should not work. If we put in 0 here, negative 5 times 0 is 0. 0 is not greater than 25. So the sign needs to flip. Okay? Let's look at a second example. Here it says x divided by 4 is greater than negative 6. Well, since we're dividing by negative 4, that means to solve the problem, since we're dividing by positive 4, that means to solve the problem, we have to multiply by positive 4. So we're going to multiply by 4 here. Notice the number in red is positive this time. Since the number is positive, that means we're not going to flip the sign. Multiplying or dividing by a positive number keeps the sign the same. Okay? So the 4's will cross each other out because of the inverse property. So we're left with an x on the left-hand side. On the right-hand side, it's negative 6 times 4, which is equal to negative 24. And the sign stays the same. Okay? So let's test this out. I should be able to put in any number greater than negative 24 into where x is and make this statement that we started with true. So let me do that. If I put 0 in, 0 is greater than negative 24, right? If I put 0 in here, 0 divided by 4 is 0. And that number 0 is greater than negative 6. 0 is greater than all negative numbers, so that's true. Okay? So again, when the number that you're multiplying or dividing by is positive, like it is here, you keep the sign the same. When it's negative, like in the first problem, it switches. So, take a few minutes, hit pause, do your one-step inequalities here, and check to see if you need to flip the sign for any of them. Okay, when you're done, hit play again on your computer, and we will take a look and see how you did. Here are the solutions. What you'll notice is that in the first problem, I had to multiply by negative 2 to solve. Since I multiplied by a negative number, the sign flipped. And negative 8 times negative 2 is positive 16. Okay? In problem 2, I divided by positive 4. Since I divided by positive 4 on both sides, the sign stays the same. And x is less than or equal to 7. Okay, third problem is a subtraction problem that you have to add 12 on both sides. There is no sign change rule when you add or subtract, so the sign will always stay the same if you add or subtract. So here you're just doing 28 plus 12 to get 40 on this side. And the 12s cancel out or undo each other on this side, so you're left with x, and x is less than 40. The last one, same thing as number 3. If you add or subtract, the sign never flips. So here we have to subtract 17 from both sides to get our solution, or find our solution set. And on the left-hand side, the 17s cancel out or undo, so we're left with an x. On the right-hand side, 24 minus 17 is 7, and the greater than or equal to sign stays the same. Okay? You can always check your answers by picking out a number that's in the solution set and substituting it back into the problem, and it should make the statement true. You can also graph these inequalities now that you have them simplified, so by drawing a number line and putting your open or closed circle in an arrow. Okay? So that's the lesson for today. Go back if you need to and watch again. Rewatch for homeworks and studying for quizzes, and I'll see you next time.